In this video, I'm going to show you how to plot horizontal translations of general functions. So here we're given a graph y equals f of x, that's this piecewise function, looks kind of like a lightning bolt, and we want to plot these two horizontal translations. First one is y equals f of x plus 5, and the second one is y equals f of x minus 7. And we're going to use this table to help us out. To understand how these horizontal translations actually translate the graph. Let's focus on this first one here, y equals f of x plus 5. So how does this translate the graph? Well, it affects the x values in the points of the graphs. For example, let's just look at this point here. This point is -2, 0, and in our table we've got a y value of 0. That comes from the function value of -2. Y is just f of x, so f of x, -2, f of -2 is just 0. And so the input to f has to be -2 to give that output of 0. Now, in f of x plus 5, how can we have the same input to f? Now this is plus 5, so in order to keep the same input to f, in order to have f of -2 as the result, we need to subtract 5 from x. Because we're adding 5. So if we subtract 5 from -2 and we get to -7, and we plug this into f of x plus 5, this comes out to f of -7 plus 5, and that's back to f of -2, which we know is 0. So bottom line here is that adding 5 here actually results in the graph, the x values have to be decreased by 5 in order to keep the same y values. That's the same here also for the point -1, 4. So y value is 4. That comes from the function value of -1. So we want the input of -1, and in order to get that input into the function f of x plus 5, we need to input an x of -6. We need to decrease that -1 by 5. -1 minus 5 is -6. So that way when we plug it into that function, f of -6 plus 5 is just f of -1, and that gives us the original y value. Okay, so bottom line, we're just subtracting from the x values here. 1 minus 5 is -4, 2 minus 5 is -3, and so on. So all these points are now shifted by 5 units. Let's go ahead and plot them. So the first point here, instead of -2, 0, that becomes -7, 0. So let's plot that. -2, -3, 4, 5, 6, 7, right over here. Okay, and then the next point, instead of -1, 4, it becomes -6, 4. So 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6 is right up here. All right, we'll label that -6, 4. And then the next point, instead of 1, 1, it becomes -4, 1. So back 4. So 1, 2, 3, 4. Right over here, label that -4, 1. And the last point, instead of 2, 3, we've got -3, 3. So -3 is right here, and we'll label that. That's -3, 3, and then we'll just connect the dots. Connect these two first. Let's draw that ray, goes down this way, and then connect these two, and then connect these two. And there we go. That is our function y equals f of x plus 5. Turns out the whole function is just shifted to the left 5 units. Adding 5 inside of the function causes the x values to be decreased by 5. I know that's counterintuitive a little, but that's just what happens with horizontal translations. Okay, so now let's take care of this second function, f of x minus 7. We can deal with this a very similar way. So if we want to maintain a y value of 0, for example, in the point -2, 0, we have to adjust the x value so that the input to the function stays as -2. So since we're subtracting 7 from the input to the function, the x value has to actually increase by 7. So -2 then plus 7 makes 5. And if we plug 5 into that function, f of 5 minus 7, that's f of negative 2, and that is indeed 0. So first point is going to be, instead of negative 2, 0, it's going to be 5, 0 now. So let's plot that. 2, 4, 5, right over here. So that's our point 5, 0. And now the next point is by the same reasoning. Originally we had negative 1 as the input, and to keep that input the same when we're subtracting 7, we have to change x to be increased by 7. So negative 1 plus 7 makes 6. Then that point is 6, and then that point is 6, 4. So let's go 6, and then up 4. That's this point here. 6, 4. And then we'll do that with the next 2 points. So 1, and then add 7 goes to 8. So the point 8, 1. So 6, then 7, 8, and that drops down to 1. It's right here. 8, 1. And then the last point was originally 2, 3, but then we got to increase the x by 7, goes to 9. And then y coordinate is still 3, so 9, 3. And that point is right over here. So 9, 3. And then we can go ahead and connect all those with our straight edge to give us the shifted function. So connecting the dots here, connect these, connect this last bit of the function here. And there we go. There is our function. That's y equals f of x minus 7. And so the result of subtracting 7 inside the function is just shifting all of the points 7 units to the right. The function as a whole is just shifted 7 units to the right. That trend that we noticed in the last example does hold in general. If we have y equals f of x plus k, if we're adding k units on the inside of the function, then that translates the original graph, y equals f of x, by k units to the left, not to the right, not in the positive direction of x, but to the left in the negative direction of x. I know that's counterintuitive, but that's the way it is. And then likewise, if we have y equals f of x minus k, for minus k on the inside, that translates the original graph, y equals f of x, by k units to the right in the positive direction of x, not the negative direction of x. So if you see plus inside, that means the graph is translated in the negative direction of x, the left. If you see minus inside, that means the graph is translated in the positive direction of x, to the right. And yes, horizontal translations happen in a way that's against your natural intuition. So this could even be a good way to remember what happens here. Just remember that the way you think the graph might be translated, just using your natural intuition is not correct. So just do the opposite of that. If you see a minus, translate it to the positive direction of x. If you see a plus, translate it to the negative direction of x. Alright, so now that we know how horizontal translations work at a high level, let's use this graph of y equals f of x to plot this translated graph, y equals f of x plus 3, and also minus 4 at the end. So we've really got two translations here. We've got this plus 3, and that is a horizontal translation. So horizontal translation. And then this minus 4 at the end, that's a vertical translation. So okay, let's take care of the horizontal translation first, just because that's a bit trickier. So horizontal translation, remember that goes against your natural intuition. So x plus 3, our natural intuition is to move it in the positive direction of x. But horizontal translations go against your natural intuition. So the plus 3 is actually translating the graph in the negative direction of x. It's moving it to the left, not to the right, to the left. And it's going to the left by 3 units. So each of these points here on the graph, just taking a few points here, each of these points is moving to the left 3 units. So let's draw that in. So that's 3 units this way, and 3 units this way, and 3 units this way, and 3 units this way. Okay, and so now we've taken care of the horizontal translation, and how about the vertical translation? So vertical translations, these work with your natural intuition. vertical translations, what you expect to happen is what indeed happens. So this -4, we expect it to go down 4, and that's indeed what happens. So let's go down 4 on each of the points. So down 4 this way, down 4 this way, down 4 this way. Oh, forgot about that one here. Down 4 with that one too. Now we're ready to plot the points. Let's plot the points. So this point here, that gets shifted left 3 and then down 4, and we end up over here. Now this point here goes left 3, down 4, we end up over here. This point, left 3, down 4, we end up over here. And this point, left 3, down 4, we end up over there. And now we can connect them up like before. So these 2 points join in a kind of curvy fashion. So do these, and then so do these. And that is then our graph here of y equals f of x plus 3 minus 4. In this video, we focused on horizontal and vertical translations of general functions, but in the future we'll also learn how to graph even more transformations of general functions, such as reflections and rescalings.